Going to explain and demo some examples from section 10.4 for you. The dominant topic of this section is inscribed angles. So in our first example, what looks like a Pac-Man who is about to eat the 90-degree arc there, we have a central angle, ABC. It's a 90-degree angle, and it's formed a minor arc that I have measured as 90 degrees. Now, what we're going to be referring to today is an inscribed angle. That's found at ADC down here. An inscribed angle is formed by the presence of two chords that intersect at one point on the circle. Two chords, right? Remember, that's a segment inside the circle, two endpoints on the circle. Whereas the sides of the angle ABC are radii, the sides of the angle ADC are just chords. So look and see that the central angle is a 90-degree angle and it forms a 90-degree arc. Now the inscribed angle also forms this 90-degree arc. It has endpoints at A and C, just like the central angle. However, if you look down at the vertex D, that does not look like a 90-degree angle. It's certainly smaller, it's an acute angle. So the principle we're going to be going by here is that the inscribed angle is always going to be exactly half of the measure of the arc that it forms. So in this case, all you have to do is divide 90 degrees by 2, and we get a 45-degree angle. And we can go both ways with this. If I had given you the 45-degree inscribed angle, you could then tell me that the arc was double that. So you can double the inscribed angle to get the arc, or take the arc measure and divide it by 2 to find the inscribed angle. You're going to see some examples in your textbook that look like this, where you have intersecting chords. I think there's 4 different chords, kind of forms a bow tie looking shape here. And we're going to use some information given to find some additional information. This problem tells me that angle MLJ is 85 degrees. That's over here, vertex at L. Now it asks us for the measure of the arc MJ. MJ, now it's from here to here. I know that because that's going to be slightly less than 180 degrees. If I were to construct a chord going from M to J, it's below the center there, so it's not quite a diameter. It's going to be a minor arc, and I can find that by multiplying my inscribed angle 85 by 2 to get 170 degrees. So if that arc is 170 degrees, that arc is associated with this angle here, but look at the angle over here at K. It also has chords that are drawn from K to J and K to M, the two endpoints that form that same arc. So by the principle where we just found that this arc measures 170 degrees from J to M, we can say that this angle in here is going to be exactly half that. So when you have this construction inside a circle like this, you're going to have two congruent angles. In this V formation, this bow tie-like shape, you'll see that you have two angles that can be marked as congruent, both 85 degrees here. Two more examples. Let's look at this one on the left here first. We have a circle. We have 3 points on the circle, Q, R, and S. And if you look closer, you can see that QS is a diameter. In this entire chapter, when you have a chord or a segment that goes from one endpoint to another endpoint and passes through the center, we can assume that it is a diameter. So based off of this, let's think about angle QRS down here. If I have a point at R and I drew a chord to Q and I draw a chord to S, and QS is a diameter, well, the arc that it forms is going to be exactly half the circle. A diameter cuts a circle in two, 180, 180. So if the arc here is 180, then my angle at QRS is going to be 90 degrees. So that is a principle you should remember. Anytime you have a inscribed angle and its arc forms a semicircle, the angle is always going to be 90 degrees. Now conveniently, that forms a right triangle for us. We have a 50-degree angle, we have a 90, so our fourth angle we know would be 40 degrees over at SQR. That's how you can do a problem like that. Last one. This is called an inscribed quadrilateral. We have a four-sided figure that's drawn entirely inside of the circle, and it has 4 sides. We know those are going to have to add up to 360 degrees. There's a principle in your textbook on page 556 that will tell you that anytime you have an inscribed quadrilateral, the opposite angles are always going to be supplementary. So if I have a 70-degree angle at GFE and I want to find GHE or EHG, I'm going to subtract 70 from 180 and find that it's 110 degrees. So up here. And we have 3 angles, so we can figure this out now, but it is going to be a supplement of 85. So up here we'd have 95. Last answer there. All right, so several examples. A lot of these, there's additional examples in your textbook you can follow along.